Okay, so we're to a new definition. It's not really new. It's something we talked about a minute ago, or in video 1, I believe. The area between the curves y equals f of x and y equals g of x. Notice that it's y in both cases. And between x equals a and b is defined as the following. And so realistically, what they want you to do with this equation is this formula, is they want you to keep whichever function is on top. And so what I mean by that is, let's look at an example, and we can split them. Find the area of the region bounded by the curves y equals sine x and y equals cos x from 0 to pi over 2. So I've already graphed this for us to save us a little bit of time. And something we can note right out the gate is this looks symmetric, and it is because these are sine and cosine, and they're just shifted versions of each other. And of course, this point here is pi over 4 because we know that the unit circle pi over 4 is where cosine and sine are equal to the square root of 2 over 2. Okay, so we're going to integrate this, and we're going to start. Notice that cosine is on top here, and sine is on bottom, so that will be our first thing. So we're going to go from 0 to pi over 4. And obviously, the reason we can't go from 0 to pi over 2 is because if we do that, notice that cosine is below sine on the second half of it, and that is a problem. So we've got that so far, and then we've got our cosine on top minus our sine on the bottom dx. Okay, so that's the first integral, and then we're going to add the area from pi over 4, pi over 2, of sine x minus cos x, okay, dx. Now, realistically, what we could do, and what we're not going to do, this would be the quicker way. This is 2 times the integral from 0 to pi over 4, cos x minus sine x dx. This is because these are equivalent because this is symmetric to this, and they're the same exact size and shape. Okay, so if we just did the 1/2 part and then times it by 2, that would give us the same solution. Okay, so let's integrate. We've got sine x minus negative cos x, integral 0 to pi over 4. We've got negative cos x minus sine x, pi over 4, pi over 2. And now we're going to start plugging in. From sine of pi over 4 is 2 square root of 2 over 2, plus, this is a plus, square root of 2 over 2, minus, and then we plug in 0. Sine of 0 is 0, and then plus cosine of 0 is 1. Okay, and then we do our addition here. Sorry, I forgot I left that out. We have the negative cosine of, we've got pi over 2. That's going to be, cosine of pi over 2 is going to be negative 0, minus sine of pi over 2 is 1. Sine of pi over 2 is 1. And then we have minus negative square root of 2 over 2 minus square root 2 over 2. Okay. So we've got a lot of signs here, so let's not mess anything up. These two combine, and that will give us 2 square root 2 over 2 minus 1. And then we have plus, this is negative 1. Distribute, these are positives now. This is plus 2 square root 2 over 2. Okay, these cancel. This leaves us with 2 square root 2 minus 2, and that is our solution to this. Okay, and you'll see right away, if you double this, you will get exactly what we have here, because it is symmetric, and that will be the solution to this equation. Okay, so everything's fine and dandy here. similar, very similar to all the other problems we've been doing. And now we're going to get into one that is not as similar. So I'm going to clean this up real quick. Go away. And let's look at the next example. So we've got, oh, not that one. This one. Okay. So we've got the following. It says, find the area of the region bounded by the curve y equals sine x and y equals oh, sorry, that's the one we just did. Find the area of the enclosed region y equals x minus 1 and the parabola y squared equals x 2x plus 6. Now, one thing you should note right away is that this one has y squared in it and a y, and all of the other ones have had a y in them. And so that is kind of important, and I'll show you why in a minute. So let's look at the graph real quick. We have this graph. If we have a handy tool like Desmos, we can see right away that if we do this, so if I do x equals negative 1 and x equals 5, you'll see that if we do the integral from negative 1 to 5, we will miss this portion right here. So we're going to miss anything to the left of negative 1 that is still part of this parabola. We can still integrate with this, and we do the area of this thing plus the area of this thing. That is one way you could do it. But one other way we can do it is we can kind of turn our paper sideways, so to speak, and use the y values instead. And so your boundaries will be from the negative 2 to the 4, and you'll solve for x because they're both in terms of x. And if you solve for x, then you'll have two new equations, and you can do it that way. It's the equivalent of just like turning your paper sideways and going, oh, now x is y and y is x, and solving it that way. So that's how we're going to actually do it. It's way more convenient to do it that way. So let's get going. Our boundaries here. So our y value, our lowest y value is negative 2. Our highest y value is 4. Okay. And then we have two equations. And if we turn our paper sideways, then the upper would be this blue line, right? Because if we turned it 90 degrees to the right, the upper would be that one and the lower would be the other one. And so let's actually, let me think, am I turning this the right way? That's the first question. All right, first thing we need to do, we need to solve for x. So we've got y squared is equal to 2x plus 6. We minus 2x. Actually, no, let's not do that. Let's move the 6 over. Minus 6, minus 6. We have y squared is equal to, y squared minus 6 is equal to 2x. We divide by 2. We have x is equal to y squared over 2 minus 3. Okay, so there's our other equation. So how do we decide? To decide which one is on the left and the right, the book is suggesting that we use the right one. Don't rotate it how I said. I said rotate it to the right. Don't do that. We're going to use the right one over the left one. Okay, so if this was sideways, we can even use these new equations if you'd like. We do have to solve for x, so this other equation is going to be y is equal to x plus 1, or no, minus 1. That's going to turn this into x is equal to y plus 1. Okay, and so let's graph those two equations, and you can kind of see right away. X is equal to y plus 1. Oh, that's the same equation, duh. That doesn't help us. I thought it was going to trick the equation, but I guess not. And then obviously if we do the other one, we have x is equal to 1/2 y squared plus 3. No, minus 3. There it is. I thought that was going to help, but I guess not. Okay, so it says to use the right one minus the left one. So the right one in this case is going to be the red line, and the left one is the blue line. Okay, so we're going to do right minus left. So the right one is going to be the equation y plus 1. Notice we have it solved in terms of x, minus the left one, 1/2 y squared minus 3 dy. Okay, so notice we're using y, so now we're using dy. Alrighty, let's combine some like terms. So this is going to give us the integral from -2 to 4. There's no other y's, but there are some other things. So let's do 1/2 y squared negative, because we distribute. And then negative and negative is plus, so that's a plus 4. So plus y plus 4 dy. All right, and now from here we can integrate. We have y to the third over 6. All I've done is, this is third power, divide by 3, multiply the 3 to the 2, and that's the 6, so this is negative. We got that, and then we have plus y squared over 2, 4y from 4 to -2. Okay, so now we're going to plug in. We have negative 4 to the third over 6. This is a 4. Plus 4 squared over 2 plus 4 times 4. And then we have a minus, and this is -2. So minus -2 to the third over 6. Sorry, that's a 2. Plus -2 squared. That's horrible. Squared over 2 plus 4 -2. Okay, and this is going to be -64 over 6 plus 16. What is this? 16 over 2, which is 8, plus 16, and then minus. No, plus. This is 8 over 6, which is 4 over 3, minus 4 over 2, which is 2, and then minus 8. Okay, 8's cancel. 16 and 2 is 14. This is 8 over 6, so -64 over 6 plus 8 over 6 is going to be, what is that? Actually, sorry, this is negative. Excuse me, that's negative because this is -8. Okay, so this one is actually negative. This is -8 over 3, and then minus that. Okay, so that's plus. Okay. So this is negative. And then I must have made a mistake, I think, right? Yeah, since I just forgot to distribute the negative, this negative goes to that. This is positive. So those don't cancel. So that's 14 plus 16. Sorry, these 8s did not cancel. These get added together. I forgot to distribute. That's very easy to forget. Okay. Now, 8 and 64, that's going to be -72 over 6 plus 30, which is -12 plus 30, which is 18. And that is our solution to this. So the area there is 18. If you want, try to do it using the other method, where you do the area 1. So where you do this area from here, this point to here. But make sure that you solve for y before you do any of that. And then do the area of this thing. I do not advise you do that, but you'll see that you will get 18 again if you do it that way. It will just be a lot more challenging. So I hope you guys are understanding what's going on here. I know the last part was a little bit slippery. I apologize for that. I hope I didn't lose anybody. like I said, it's very easy to forget negative signs, and we have to be very careful. So thank you guys for watching, and I hope you're doing well. Take care.